So first step is row reduction and the second step is column reduction, and the next step row scanning, the next step is column scanning. So by using this column reduction matrix values, we can find the row scanning also, because in last row you have only one zero. If you selected this zero as assignment, you can't select in a last row. Can't consider this zero as the least value because all the diagonal matrix values are always zero or infinity. Hello everyone, I am Shweta, Computer Science Faculty, Vidhyaashram First Grade College, Mysuru. In my previous session, I have discussed traveling salesman problem by inspection method. So in inspection method, if you not get direct method, so you can go for inspection method. In inspection method, we can modify the assignment. If it is not a direct method, so we can modify the assignment. So today I will explain some other important problems on traveling salesman. So first problem, here you have 5 number of columns and 5 number of rows. So all the diagonal matrix values are 0. Why it is 0? Because salesman can't travel from A to A, B to B, C to C, D to D and E to E. What are the conditions of traveling salesman problem? He has to visit all the city exactly once and he must return to the same starting point. So here in first problem, we have number of columns and rows. This is your matrix representation. So first step. So what is the first step? So here also we have to apply assignment problem by Hungarian method. Same assignment problem by Hungarian method we are applying in this problem also, but the assignment is different. Here first we have to find row reduction or row minimum. In first row, which is the least value in first row? The least value in first row is 2. So subtract the other value, 3 minus 2, 6 minus 2, 8 minus 2, 2 minus 2 is 0. And in second row, the least value is 3, 7 minus 3, 4 minus 3, 9 minus 3 and 3 minus 3. And in third row, the least value is 5. 9 minus 5, 4, 8 minus 5, 5 minus 5, 8 minus 5 is 3. And in the fourth row, the least value is 5. 13 minus 5, 8, 0, 2 and 1. In last row, the least value is 2. So listen carefully, you can't consider this 0 as the least value because all the diagonal matrix values are always 0 or infinity. So here, no need to consider this 0 as the least value. Other than this diagonal matrix, you can consider the least value. In last row, the least value is 2, 2 minus 2, 4 minus 2, 3 minus 2 and 9 minus 2. So this is your row minima, that is row reduction values. Now, I will find out the column minima. By using row reduction values, I can find out the column reduction values. So, in first column, the least value is 0, but not this 0, the least value is 0. You are not supposed to consider this 0 as a least value. And in second row, so least value is 0. So again you will get the same value. And in second column, the least value is again 0, 1, 3, 0 and 2. And in the third column, the least value is 1. 4 minus 1, 1 minus 1, 2 minus 1, 1 minus 1. And in the fourth column, the least value is 0, 6, 6, 0 and 7. And in the last column, the least value is again 0, 0, 3, 1. So this is your column reduction values. By using this column minima or column reduction matrix values, we can find out the assignment. So next step is row scanning and column scanning. So this is your column reduction values. By using this, I can assign the zeros. So first I will find out row scanning. In first row, I have 1, 0, except this diagonal matrix. I have 1, 0, put a square box around that 0 and put a vertical line. And in second row, I have 1, 0. And in third row, I have 1, 0. In fourth row, I have 1, 0. In fifth row, I have 1, 0. So now, all the assignment has finished. So you can cross verify whether it is satisfying the optimality solution or not. Here, the number of square marked, it should be equal to number of rows. How many square marked are there? 1, 2, 3, 4, 5. So number of square marked is equal to number of rows. We have 5 square marked, 0 assigned, and 5 number of rows. Is it equal? Yes, it is equal. It's satisfying the optimality condition. Next step is assignment. We have to find the assignment here. So, optimal assignment is salesman travel from A to E, A to E, and E to A. So here he traveled from A. He started his journey from A and he traveled to E and again E to A. He returns back to the same position. But without visiting this other cities, he traveled from A to E, E to E. But without visiting other cities, directly he traveled from A to E and E to A. So it is not a complete route. So here traveling salesman condition has not satisfied. So what is the next step? So, and he has traveled from B to C, B to C, C to D and D to B. So condition is not satisfied. If the condition is not satisfied, so what is the next step for finding the new assignment? So here we have to modify the assignment by inspection method. So here have assigned 5 zeros. You just observe these zeros. In first row have assigned this 0. In second row have assigned this 0. In third row have assigned this 0. Fourth row and fifth row. But this 0 assignment has not satisfying the traveling salesman problem. So we have to modify the assignment. Here first I will write the matrix values. Fifth row it is 0, 2, 0 and 7. So now I will modify the assignment. In previous assignment, I have assigned this 0. But this 0, if you assign that 0, so salesman problem condition is not satisfied. So what I will do is, so next I will consider the next least value in the matrix value. So next I will consider, instead of this 0, I will assign the next least value. So next least value is 1. So in first row I have assigned this 1. So next least value is 1. I have assigned this 1 and I can cancel this 0. So put a vertical line. And in second row I will assign this 0 and put a vertical line and you can cancel this 0. So in previous matrix also I have assigned the same 0. And in third row I will assign the same 0. So I will assign this 0 and put a vertical line. And in fourth row, in previous matrix representation, in fourth row I have assigned this 0. If you assign this 0, the condition is not satisfied. So here already in first row I have assigned this 1 as an assignment. So below that you can't assign any other 0. So in fourth row I am assigning this 1 as an assignment. So you just cross verify the previous matrix values and this representation. So now I am assigning this 1 as an assignment. So previous matrix it was the 0 as an assignment. So next I will consider the next least value. This 1 I can't consider because over that I have assigned already 1 more 0. And in the last row I am assigning this 0. So now you can cross verify whether it is satisfying the optimality condition or not. So in first row I have assigned this 1 and second 0, 3, 4 and 5. So number of square mark is equal to number of rows. It's satisfying the optimality condition. Now you can cross verify the traveling salesman problem condition is satisfied or not. So he traveled from A to B, then B to C, then C to D, and D to E, and E to A. So now he started his journey from point A and he traveled to B, B to C, C to D, D to E, and again E to A. Again he must returns back to the same point. So now the traveling salesman problem condition has satisfied. So next step you can find the total cost. So here he travels from A to B. The original value of A to B is 3. 3 plus B to C. B to C is 4 and C to D. C to D is 5 and D to E. D to E is 6 plus E to A. E to A is 2. So total cost is 7, 12, 18 and 20. So 20 kilometers. So total cost is 20. So this is about your traveling salesman problem. If traveling salesman problem has not satisfied the conditions, so you can modify the assignment by using the next least value. The next least value is 1. So I have assigned 1 as an assignment. And here in the 4th row also I have assigned 1 as a least value. So I have assigned 1 as an assignment. So next you will get the traveling salesman problem condition satisfied. So it is very simple concept. Please understand the concept. Easily you can score in traveling salesman problem also. So next problem is second one. Here you have 5 number of columns and 5 number of rows. So here all the diagonal matrix values are infinity. So what is the first step? So first step is row reduction and the second step is column reduction and the next step row scanning. The next step is column scanning and next you have to find the traveling salesman problem condition are satisfied or not. That means we have to find the optimal conditions. So here in first row the least value is 4. The least value is 4 means 7 minus 4 is 3. 6 minus 4, 8 minus 4, 4 minus 4. In second row, the least value 5. So 7 minus 5 is 2 and 3, 0 and 1. In third row, the least value is 6, 0, 2, 3 and 1. In fourth row, the least value is 5. It is 3, 0 and 9 minus 5 is 4 and 8 minus 5 is 3. In last row, the least value is 4. So 4 minus 4, 6 minus 4, 7 minus 4, 8 minus 4. And now we can find the column reduction. So in first column, the least value is 0. So again you will get the same value. So 2, 0, 3, 0. In second column also least value is 0. 3, 2, 0 and 2. In third column, the least value is 2. So 0, 1, 2, 1. In fourth column, the least value is 0. So 4, 0, 3 and 4. In last column, the least value is 0. You will get the same value. So now column reduction has completed. The next part is row scanning. So by using this column reduction matrix values, we can find the row scanning also. So in first row, I have 2 zeros. In first row, I have 2 zeros. Just skip that row and you can go for second row. In second row, I have 1 0. Put a square box around that 0 and put a vertical line. And in third row, I have 1 0. In fourth row, I have 1 0. And in fifth row, no zeros, 1 0 also cancelled. So row scanning has completed. The next step is column scanning. So first column, second column and fourth column cancelled. So third column I have 1 0 and in fifth column no zeros. So here we have to check whether it is satisfying the optimality condition or not. Here I have assigned only 4 zeros. The number of square marked is equal to 4. So number of square marked is equal to 4 and number of rows are 5. So 4 is not equal to 5. It is not satisfying the optimality condition, right? So what is the next step? So already I have discussed in Hungarian method also. If it is not satisfying the optimality condition, so we can move to the next step. So what is the next step? So these are the deleted cell values and undeleted cell values. Among these undeleted cell values, choose one least value and subtract with other values. So least value is 1. Subtract with that value. So it is 0, 0, 0, 2 minus 1, 3 minus 2 and 1 minus 1. And the remaining values are same. So 2, 0, 3, 0, 2, 0, 3, 0. Next, accept this common for both horizontal and vertical point. So this is common for both horizontal and vertical point. So 3 and 4. So you just add that least value with that value. So 3 plus 1 and 4 plus 1. The next other values are same. 2, 0, 2 and this 4. So now again you can go for row scanning and column scanning. In first row I have 2 0, skip that row, and in second row also I have 2 0, third row also I have 2 0 and in fourth row I have 1 0. I have assigned this 0 and put a vertical line, and in fifth row also I have 2 0. Just skip that row. And now I can go for column scanning. In column scanning, in first column I have 2 0, third column 2 0 and in fourth column I have 1 0. Put a horizontal line. In fifth column I have 2 zeros. So here the assignment has not completed. I have assigned only 2 zeros here. So first I will choose this 0 and I can cancel this, and next I will choose this 0. So you can cancel this, and in column also you can cancel this 0. In third row I will select this 0 because in last row you have only 1 0. If you selected this 0 as assignment, you can't select in a last row. So I have selected this 0. You can cancel this. In fifth row, in fourth row I will select this 0, and in fifth row I have selected this. So now number of square marked are 5. 1, 2, 3, 4, 5. I have assigned 5 zeros. So now you can cross verify whether it is satisfying the traveling salesman problem condition or not. He visit A to C, then C to E and E to A. He travelled from A to C, C to E and E to A. Without travelling other cities, he travelled from A to C, C to E and E to A. So, the travelling salesman problem condition has not satisfied. So, what is the next step? So, first I will write the matrix values. 4, 0, 5, 0, 2, 0, 0, 0, 0, 2, 3, 0, 3, 0, 1 and 2, 0, 2, 0, 4. So now in previous assignment you can observe this. If you assign this 0, so it is not satisfying the travelling salesman problem condition. So now I will assign the next least value. So which is the next least value? In first row, the next least value is 4. So I will assign 4 as an assignment. So I can cancel this 0. Clear? And in second row, in previous matrix representation, I have assigned this 0. So again, I will assign this 0 and I can cancel this zeros. And in next step, again, I will assign this 0 and I can cancel this. And in fourth row, you can't assign this 0 as assignment because over that I have assigned 1, 4. I have assigned one assignment here. So you can't choose this So I will assign the next least value. So in this row, the least value is 1. So I will assign this 1 as an assignment. So in last row, I will assign this 0 and I can cancel this. So now you can cross verify whether it is satisfying the optimality condition and traveling salesman problem condition. So we have 1, 2, 3, 4, 5. So 5 is equal to 5. It's satisfying the optimality condition and he starts from, salesman started his journey from A to B. Salesman started his journey from point A and he visits B. A to B, B to D and D to C, C to E and E to A. So now it is satisfying the traveling salesman problem condition. So now you can find the total cost. This is your assignment now. It's satisfying the traveling salesman condition. So what is the total cost? Travels from A to B. So original value of A to B is 7. 7 plus B to D. B to D is 5. And D to C. D to C is 9. And C to E. C to E is 7 plus E to A. E to A is 4. So total cost is 12. 12 plus 9 it is 21, 28, 32. 32 kilometer he travels. So total cost is 32 rupees. So this is called as traveling salesman problems. In my next session, I will discuss some other problems on traveling salesman method. Thank you.